All right, so this is our study guide. You guys should have a copy of your own. Make sure that you put your name, your date, and the period. I may or may not be collecting these. I may or may not let you use them tomorrow. So we have done these numerous times, and I want to make sure that we show off our best skills here. So we're going to focus on this. It says Mario drove his go-kart 1/2 of a mile in 3/8 of an hour. Use the table below to find how many miles he drove in an hour. Okay, so we are trying to find miles per hour. And I'm going to go ahead and label everything because now I know that I can. That's Y and that's X. I'm going to go up here and put Y here. I'm going to put X there. Do I have to do all that nonsense? No. Can it help you? Probably. So we are going to use that form to figure out how many miles he drove in an hour. Now, I don't know what the A, B, and C is, but the way that it looks to me is that in A, I need to put this, because it already tells me it's 1/2 of a mile per 3/8. That just comes straight from the story. So I'm going to fill that in. That one was easy. Okay. But now we need to find out per hour. So I'm going to use, let's change the color, use this formula. And so that I can focus, I'm going to make that bigger for my brain. And this, to me, just says it's a division of two fractions. So I'm going to write it a little easier. 1/2 divided by 3/8. Okay? Well, I know dividing fractions is just keep, change, flip if I'm dividing fractions. So I'm going to multiply across the top. I get 8. Multiply across the bottom. I get 6. Now, I also know that I cannot leave it that way. So I have to simplify that. If you do not know how to simplify, figure out how many 6's, your bottom number, your numerator, you have in the top. I have 1 and 2 extras. And I have a 6 still on the bottom. That didn't change. But because I have 1, I have a whole. So that'll be 1 and 2, 6. Now, can I leave it like that? Nope. Because that 2, 6 can be simplified as well. So that'll be 1, or divided by 2, divided by 2. The final answer is 1 1/3. So I'm going to fill this in. Let's make sure. It's trying to find out miles per hour. So miles per hour, it went 1 1/3 miles per 1 hour. So 1 1/3 miles in 1 hour. And so we'll fill this in down here. 1 1/3. When you're taking this on Performance Matters, they may have you drag them where they're supposed to go. But I'm just kind of reminding you that no matter how you see it, you're going to have to figure that part out. Knowing the math is the most important part. All right, this one says Peach's honey mustard calls for 3 1/4 of a cup of honey for every 6 pints of mustard. So honey per mustard. Yep, that's what it says. Peach will need to use blank cups of honey when she makes her honey mustard sauce with 1 pint of mustard. So this will be honey per mustard. Again, honey is my Y, mustard is my X. Do I need to know that? Later I will. Okay. So I am going to do a division problem. Y divided by X. So I'm going to plug in my Y, 3 1/4 divided by 6, which is my mustard. That's a division problem. So I am going to go over and say 3 1/4 divided by 6. Well, here's the problem. I have a fraction. So I have to do something that I remember how to do from the beginning of the year. I have to do that 3 times 4 plus 1. Change that into an improper fraction. 3 times 4 is 12, plus the 1 is 13 over 4. divided by 6, okay? Now that 6 is technically over 1. Now I'm dividing fractions. Dividing fractions means I'm going to keep, change, and flip. So now I multiply across the top, 13, across the bottom, 24. Does that make sense is my last question, because you know I get a little concerned when it's weird, but I know that somebody made these up. So let's think about whether or not this makes sense. Okay, this is just, I'm going to switch colors so that my head can go there. So that is saying 3 1/4 is the honey for 6 mustards. Okay, and it's telling me 1 mustard will be 13/24. So this got smaller by 6. This got smaller by 6. So yeah, it does make sense. I'm doing that just because it came out weird. I'll be honest, I don't remember on the test if it comes out weird, but I want to make sure that you know how to test it in terms of common sense. Does that make sense? And it makes sense that it got smaller. So we're going to put 13 over 24 cups of honey when she uses to make her honey mustard sauce. She's just not making as much. Okay, push pause. Go ahead and try number 3. Yoshi is clearing Koopa shells from his track. I'm assuming this person plays Mario. The table below shows how many yards he has cleared over time. Okay, so he clears 3/4 in 3 days, 1 1/4 in 5 days, 1 3/4 in 7 days. How many days does it take to clear 1 yard? Well, we want to know per day, right? So that is yards per day. We figured that part off. So I'm going to go ahead and just write it. 3/4 yards per 3 days. Well, that just means division. So 3/4 divided by 3 over 1. I'm going to keep change and flip. 3/4 times 1 over 3. Oh, okay. So, wait. 3 over 12. No. Maybe. 3 over 12 will then reduce, because 3 divided by 3 and 12 divided by 3 is 1/4. Well, that'll make sense. Okay, so it's saying it'll take 1/4 of a day to clear 1 yard. That doesn't make sense. Why doesn't it make sense? Because it's saying it doesn't even clear a whole yard in 3 days. Yards per day. Okay, I know that you guys are probably sitting there going, I know why, I know why, I know why. But I'm not doing a very good job of finding the why. So yards per day. So yards is on top, 3/4 divided by 3. Okay, so I don't like it. Oh, okay. Let's plug it in, guys. I figured it out. Okay. We figured out 1/4. Well, let's think about where that 1/4 goes. Okay. 1/4 yards per day. And that is right. Okay, so let's think about, remember what we said up here? Let's say it. 1/4 yards per day. Okay, so now let's common sense it. How many days does it take to clear 1 yard? Well, if I only get 1/4 in a day, 1/4 in another day, and 1/4 in another day, and a 1/4 in another day, it took me 4 whole days to finish a yard. Could I have done that differently? Yeah, I could have set it up differently, but my brain didn't want to do that. Could I go back and do that? Yes. Is there anybody in there? Raise your hand that did do it a different way. Maybe you did it per yard, days per yard, instead of yards per day. But I'm sorry, I've mowed a lawn, and if it takes me 4 days to mow a lawn, I'm not mowing that lawn anymore. I'm going to hire somebody. So, and I'll have more people mowing it. So maybe that's where my brain needed it to be yards per day, because again, I don't want to spend 4 days mowing a lawn. That doesn't sound right. So I apologize that I'm having a moment, but maybe that moment will help you. Okay, so thinking about what we figured out there. I had to plug it in. I had to think about it because the way that we wrote it was yards per day. And it's asking about how long did it take to clear 1 yard. Well, guess what? What I calculated was yards per day. So I needed to flip it. Complicated. It shouldn't be complicated. There's another way that I'm going to show you that my students showed me last year that you might like better, but I do believe that it works on the test. So here's what they noticed. If I change this to an improper fraction, okay, that'll be 5/4. Now somehow they made a connection, but I think because this is done backwards, that's why the connection is not making it. But there was students that figured out that you got 1/4 over here that went with 1. They figured out the pattern that went with that. 1/4 went with 1. So again, I think that because my brain has seen this problem done differently, that's why. But that is what some students saw, was that, well, if it took them 3 days to do this, then, and I couldn't argue with them. Push pause and try to give this one a try. The cost of coconuts is proportional to their weight. Donkey Kong loves coconuts almost as much as he loves bananas. A 64-ounce bag of coconuts is being sold for $4. So cost per ounce. AOUNCE. That's the first thing I've got to do because it's unit rate, okay? So we're just going to divide the two numbers. I need to remember which one to put first. Since it says cost, I know the cost is 4 divided by the ounces, 64. So sorry. So the problem is students are going to want to do it the wrong way. So we're taking that 4 and dividing it by 64. So we're going to have to do a lot of work. And you know that Miss Eringer is not great at these. But I know that 64 does not go into 4. So I'm going to put an X there. Or 0, whichever one you want. Okay. 64 cannot go into 40. So I'm looking at these numbers. So I'm putting another 0. 64 can go into 400, and I need to figure out how many times. So I'm going to guess 64 times, I should know this better, but let's try 4. I don't know if that's right or not. So 16, carry the 1. 24, 25. Okay, that's not big enough. So I'm going to give it one more. So this will be times 5. Will be this answer. 0, carry the 1. That is 11, 12, 1. It's 320. Still not enough. So I'm going to put a 64 here. Times 6 will be this answer. 4, 8, 3. So that's as close as I can get is the 6. So I'm going to put the 6 right there, 6 cents. 3, 8, 4. I'm going to subtract. I have to borrow. Okay, so 10 minus 4 is 6. 9 minus 8 is 1. Bring down the next 0. Bring it on down and bring it on back. Divide. How many times does 64 go into 160? Maybe twice. Maybe twice. So 64 and 64. 138. Yep, that's it. Twice. 0.62. Now, I know that I have kids going, Miss Eringer, don't you know that that's cost, so you can't go to a 3 decimal places? And I'm going, right, but I need to know whether or not I need to round that up from 6 cents to 7 cents. And since it's a 2, I can stop right there. The unit rate would be, oh, that's the wrong thing. 0.06 cents per ounce. Okay, I'm going to have you push pause now so that you guys can try number 5. Here is number 5. The equation y equals kx defines the proportional relationship between x and y, where k is the constant of proportionality. Please write down the constant of proportionality k is. Okay, so this one doesn't give me any information. So k equals y over x. 0 over 0 doesn't tell me anything, but this one will. So I'm going to put y over x, y over x. Y is 2 over 6, which equals 1/3. Y is 4 over 12, which equals 1/3. Now, I know that we did a bunch of those, so you better know how to do that. Okay, number 6. Please push pause, give it a try. Okay, number 6 is again about, I guess, Mario Kart. The tables below show the different tracks you can drive in Super Mario Kart. Teacher edition. Ooh. Students, Luigi and Toad must drive the track series that is a proportional relationship. Toad thinks that it's track A, and Luigi thinks it's track B. Who is right? And explain your answer. Oh, cool beans. We just get to find out if these are proportional or not. So let's see. This one would be, let's see, we'll pick, I don't know which one is y and x. So we're going to go with y is, that y is here, x is here, y is here, x is here. So if I put 175 over 100, I don't want to reduce that one. So let's look at the next one. 350 over 200. Well, I know to reduce that and get rid of zeros. So now I have 35 over 20. I'm going to zoom so that hopefully you guys can see it a little better. They're both divisible by 5. So I get 7 over 5 for that one. Okay, now let's check our other numbers. Oh, 7 and 400. 20 divided by 5 is 4. And the last one is 700 over 400. Well, guess what? If I divide them both by 100, or since they both have zeros, I can cancel them out, it equals 7 over 4. So now I just need to test this one. What is 100 divided by 4? That's 25. So that would be 4. 175 divided by 25. I'm going to count my quarters. 25, 50, 75, 100, 125, 150, 175. So yes, this one is proportional. Proportional. So I don't have to check the bottom one, but I do have to explain it. So let me see the explain. I'm going to go to text. I will make it a little bigger so that you guys can see it, I hope. Track A is proportional because the constant rate is 7 over 4 for all of the tracks. Ta-da! So if you need to take a moment and push pause to get everything written and to move on to the next problem, please do so. We're going to do number 8. Match the situation with the correct equation. All right, so since we're matching the equation, so A is 4 over 2, or 8 over 4. Both of those are reduced to 2. And I know that my equation is y equals kx. If x is 2, this one is A. Okay, let's try the next problem. I'm going to change colors. That might be easier. Okay, so we're going to put 10 over 2 and 15 over 3. 10 divided by 2 is 5. 15 divided by 3 is 5. So that means my k is 5. So y equals 5x. This one is B. We will change our colors. Yuck. Mario eats 3/4 of a pizza in one sitting. So 3/4 divided by 1 is just 3/4. I'm just going to write that. But then the other one would be 6 divided by 8, which simplifies. If I divide them both by 2, I get 3/4. So my equation for that will be y equals k, which is 3/4 x. I'm sorry, it's so tiny. So this one is C. Okay, now this last one that we have to do is graphing. And I know that it seems like graphing is complicated, but it really shouldn't be complicated. Okay, we have X and Y. We're going to first label, if it's not already labeled for you, graph the relationship between hours a day drinking coffee. So drinking, I'm going to make sure to put coffee behind it. And then work is over here. Okay, now, since these are, I'm going to label them, I've got points. This is 1, 2, 3, 4. But they have that half in there. So I kind of need to do a half somewhere, right? So I'm going to label this 1/2. This will be 1 1/2. And I'm doing this because I know what the test is going to be. This one is 2 1/2. Now, I'm hoping you guys can figure out that those are all 1/2 jumps, but you're going to have to be able to graph them on your own. Well, since it says that 1 1/2 an hour drinking coffee, okay, so I'm going to start with drinking coffee. It's going to come along this little line, doop-de-doop-de-doop-de-doop-de-doo, right there. And then I need to figure out where 2 days of work is. Doop-de-doop-de-doop-de-doop-de-doop-de-doo, there. Okay, so I have the first one. Now I need to figure out where the other one is. So I have to find that constant. Like, how is it moving? And to do that, you're going to divide them. Y divided by X, right? So Y is the green, drinking coffee. So 1 1/2 divided by 2. Well, I already know the answer to that, but I shouldn't. So I'm going to change this into a division problem. 1 1/2 divided by 2. I'm thinking of money already. $1.50 divided by 2. I have to do that little turn thing. So that is 3/2 divided by 2 over 1. And I'm going to change it. Keep. Change. Flip. So 3/4 an hour per day drinking coffee. Okay. So what that means, okay, it's 3/4 is my Y and 1 is my X, okay? So when that comes to graphing, what that means is my up is 3/4 for every 1 that way, okay? So let's start at our 0, 0, okay? Let's go up 3/4, which would be, well, here's 1/2, so 3/4 will be right there, okay? So plus 3/4, okay? Then my Y was over 1, So there's the first point. Okay. Let's see if I add 3/4 again. If I go up 3/4 my y and then over my 1, does it equal? Yes. So that is how you will do your graph. Actually, the point would be there. And we will be doing more with this in the future. But there's that one.